This is NASA's Perseverance rover, and this is China's Zhurong rover, named after the Chinese god of fire. Both machines are rolling across the red planet right now, and their presence marks more than exploration. It signals a growing rivalry reaching beyond Earth and into deep space. Now, before Zhurong even touches the Martian surface, we need to understand the gap it's trying to close. The United States enters this mission with over 50 years of Mars experience, sending multiple landers and rovers. China, by contrast, only launched its Mars program in 2006, yet it arrived with bold ambition today and seeks to prove itself. And here's where China's Tianwen-one mission becomes such a giant leap. Instead of taking the traditional step-by-step approach, China went all in with an orbiter, a lander, and a rover, three major components on a first attempt. That alone is incredibly ambitious. But Zhurong's real challenge begins with landing safely on Mars, something even veteran space agencies struggle with. As astrophysicists remind us, Mars is tricky. Its thin atmosphere makes parachutes far less effective, yet it still has too much air for pure rocket braking like we use on the Moon. So China chose a hybrid solution, parachutes to slow down, thrusters to finish the job, hoping this balance brings Zhurong gently to the surface. When it comes to landing on Mars, the location you choose can make or break the entire mission. That's why China selected Utopia Planitia for Zhurong, a broad flat plain that dramatically lowers the risk of landing hazards. It's the same region where NASA's Viking 2 touched down way back in 1976, proving it to be one of the safest places on the planet. Perseverance, on the other hand, took a far more daring approach. NASA targeted Jezero Crater, a rugged landscape shaped by ancient rivers, complete with steep crater walls, rocky hills, and remnants of a long-dead delta. It's a far more dangerous place for a rover to land, but it also holds some of the richest clues about Mars' watery past. Different strategies, different risks, but both aimed at big discoveries. Now let's talk about how each rover actually reaches the Martian surface. NASA's Perseverance uses the famously complex sky crane system. During descent, the rover literally hovers above the ground, while a computer vision system scans the landscape in real time, dodging rocks, slopes, and anything that might end the mission instantly. China's Zhurong, however, takes a more traditional approach, deploying a parachute to slow down through the thin atmosphere, then firing rocket thrusters for a controlled, gentle touchdown. It's simpler but highly reliable, and that difference makes perfect sense. Rugged Jezero Crater demands cutting-edge precision, while the smoother plains of Utopia Planitia allow for a more conventional descent. Once Zhurong reaches the surface, China's first priority isn't to chase groundbreaking discoveries. It's to master the fundamentals of working on Mars. That's why the rover is equipped with tools that are modern, reliable, and very familiar to scientists. Its technology is roughly on par with NASA's Spirit and Opportunity rovers from the early 2000 era, a smart choice for a first mission. Zhurong carries a multispectral camera to study Martian rocks in different wavelengths, helping identify their composition. And perhaps most importantly, it features a ground-penetrating radar, a powerful instrument capable of detecting layers beneath the surface, including buried water ice. These tools may seem modest compared to Perseverance's arsenal, but they're exactly what China needs to build long-term expertise on the Red Planet. Compared to Zhurong, NASA's Perseverance arrives on Mars as a much larger and far more capable scientific platform. Its extra size isn't just for show. It allows NASA to pack in some of the most advanced instruments ever sent to another world. One of the standout features is Ingenuity, the tiny helicopter that made history as the first controlled aircraft to fly on a planet other than Earth. That experiment alone pushes the boundaries of what future explorers might do on Mars. But Perseverance's main mission goes much deeper, searching for signs of ancient life. To accomplish that, the rover relies on a sophisticated robotic arm equipped with a drill capable of extracting rock cores and scooping loose soil. Each sample is sealed inside a pristine metal tube, protected from contamination, and stored securely within the rover's body. NASA aims to bring these samples back to Earth by 2031, If successful, it could give humanity its first real chance at analyzing Martian material in cutting-edge laboratories here at home. When we talk about the Mars race between China and the United States, there's a major factor that often gets overlooked: political stability. China's space program has enjoyed unwavering support from top leadership ever since the era of Mao Zedong, and that continuity matters. Unlike countries where priorities shift every 4 or 5 years with each election cycle, China can commit to ambitious, decades-long plans and actually stick to them. This stability is matched by serious financial investment. China operates 4 space launch facilities, more than any other nation, which shows just how strongly the government backs its push into deep space. That kind of infrastructure doesn't appear overnight. It's built through long-term commitment. Meanwhile, NASA operates in a very different environment. As a civilian agency, its budget rises and falls depending on which administration is in power and how Congress chooses to allocate funds. For at least 2 decades, NASA has announced goals like returning to the Moon or accelerating Mars exploration, only for political shifts to slow or redirect those plans. So in the global space race, China's consistent vision gives it a strategic advantage that the United States can't always match. When we look at how China and the United States fund their space programs, we can clearly see why their strategies diverge. China runs a fully centralized, state-funded system, one unified program with a single long-term vision. That structure allows for consistent investment and rapid execution. Meanwhile, NASA operates as an open civilian agency. Its technology is shared, its data is public, and collaboration is part of its DNA. But that openness also means NASA depends heavily on commercial partners like SpaceX to carry out major missions. This partnership model supercharges innovation, yet it also makes NASA vulnerable to political and budget shifts. In short, different funding models create fundamentally different paths to the future of space exploration. If Zhurong completes its mission, China won't just land a rover, it will make history. In one bold stroke, China would achieve more on Mars in far less time than the United States did, reinforcing its narrative of rapid technological rise. And this success isn't isolated. It pushes China closer to long-term ambitions like building a lunar base and expanding its own space station. For China's leadership, Zhurong is more than a robot. It's proof that their political and technological model can outperform traditional space powers. So the world is watching closely. If Zhurong wins, China's message becomes undeniable.